start on Black Holes, Chapter 6, Hawking's Big History of Time. The term black hole is of very recent origin. It was coined in 1969 by the American scientist John Wheeler as a graphic description of an idea that goes back at least 200 years, to a time when there were two theories about light. One, which Newton favoured, was that it was composed of particles. The other was that it was made of waves. We now know that really both theories are correct. By the wave-particle duality of quantum mechanics, light can be regarded as both a wave and a particle. Under the theory that light is made of waves, it was not clear how it would respond to gravity. But if light is composed of particles, one might expect them to be affected by gravity in the same way that cannonballs, rockets and planes are. At first, people thought that particles of light travelled infinitely fast, so gravity would not have been able to slow them down. But the discovery by Römer that light travels at a finite speed meant that gravity might have an important effect. On this assumption, a Cambridge Don, John Mitchell, wrote a paper in 1783 in the Philosophical Transactions of the Royal Society of London, in which he pointed out that a star was sufficiently massive and compact, would have such a strong gravitational field that light could not escape. Any light emitted from the surface of a star would be dragged back by the star's gravitational attraction before it could get very far. Mitchell suggested that there might be a large number of stars like this, although we would not be able to see them because the light from them would not reach us. We would still feel their gravitational attraction. Such objects are what we now call black holes, because that is what they are. Black voids in space. A similar suggestion was made a few years later by the French scientist, the Marquis de Laplace, apparently independently of Mitchell. Interestingly enough, Laplace included it in only the first and second editions of his book, The System of the World, and left it out of later editions. Perhaps he decided it was a crazy idea. It was a bit crazy. Also, this is in brackets, the particle theory of light went out of favour during the 19th century. It seemed that everything could be explained by wave theory. It was not clear that light would be affected by gravity at all. In fact, it is not really consistent to treat light. In fact, it is not really consistent to treat light like cannonballs in Newton's theory of gravity, because the speed of light is fixed. Brackets. A cannonball fired upward from the Earth will be slowed down by gravity and will eventually stop and fall back. A photon, however, must continue upward at a constant speed. How, when can Newtonian gravity affect light? Consistent theory of how gravity affects light did not come along until Einstein proposed general relativity in 1915. And even then, it was a long time before the implications of the theory for massive stars were understood. That's enough, folks, for now.
Bye.